So we've learned about three very important measurements in analytical geometry, namely distance, midpoint, and the gradient of a line. So say we have 2 points, coordinates x1, y1, and x2, y2. What we've learned is that the distance between those 2 points is given by the square root of the difference between the x coordinates and the difference between the y coordinates. We've learned that the midpoint is given by the average between the x coordinates and the average between the y coordinates. And we've learned that the gradient is given by the difference between my y coordinates divided by the difference between my x coordinates, paying careful attention to the order that I use, right, because direction matters. So for example, let's give these formulae a test run. Say we had to find the distance, the midpoint, the gradient of the line between the points. Right, 3, 8, and minus 1 and 0. And typically, what's very useful with these kinds of questions is to do a very quick sketch, just so you have a bit of a sanity check measure in place once you have your answers. So 3, 8 is going to be somewhere here, and minus 1, 0 is going to be somewhere here. So we're expecting a positive gradient, for example, and if you're to work out your midpoint and get a point that's somewhere over there, then you know that something has gone awfully wrong. So to work out the distance, we're going to say change in x, so 3 minus 1 squared, plus change in y, so 8 minus 0 squared. And order doesn't really matter with this, like I've said before, because the difference just ends up getting squared anyway. So that would be 16 plus 64, which is 80, and that is 4 root 5 units. So if you're asked to give your answer in third form, then it's perfectly fine to leave it like that. Otherwise, as a decimal, this is roughly 8,94 units. So that would be the distance between those 2 points. And of course, there's no need to do this calculating. You could just punch this straight into your calculator. In fact, you could just punch this into your calculator and jump right from there to over here, and that would be perfectly acceptable. Right, the midpoint is given as the average between my x coordinates and the average between my y coordinates, and that would be 3 minus 1, which is 2 over 2, which is 1, and 8 plus 0 over 2 is just 4. So, and that kind of makes intuitive sense, right? We move that way and we move up to 4. It kind of makes sense. Anyway, and then the gradient finally would be my change in y's over my change in x's. So 0 minus 8 over minus 1 minus 3. That would be minus 8 over minus 4, which is positive 2. And my line does have a positive gradient, so that's great. Of course, you could also have said 8 minus 0 over 3 minus 1. So 8 over 4 also gives me 2. Right, let's do another example. Cool, let's determine all these measurements for the points 6 minus 3 and 6, 5. So like I said, always useful to first do a sketch. So 6 minus 3 will be down here somewhere, and 6, 5 will be up here somewhere. So we're talking about a vertical line. Right, and the distance between them, I mean, you really don't have to go through the admin of using these formulae, but let's just use them anyway to see that they do work even in these cases where these measurements are a lot more intuitive to do. So my distance would be the square root of change in x, which is nothing, plus change in y. so minus 3 minus 5 squared, and that would be 0 squared, which is just 0, and minus 3 minus 5 is minus 8 squared is 64. The square root of 64 is just 8 units, and that makes sense. To go from 6 minus 3 to 6, 5, you know, we go up 3 units and we go up another 5 units, so it makes sense that the distance is 8 units, right? And then the midpoint is going to be the average between my x coordinates, right? And in this case we expect that it will remain 6, and the average between my y coordinates, so that would be 12 over 2, which is 6, minus 3 plus 5 is 2, divided by 2 is 1, so that would be my midpoint. And again, that makes sense. So to get from 6 minus 3 to 6, 1, I've gone up 4 units, and to go from there to 6, 5, I go up another 4 units, so that makes sense as a midpoint. And then finally, the gradient we're expecting to be undefined because this is not the kind of mountain we want to climb. So difference between my y's, so let's say 5 minus 3, and then difference between my x's is 6 minus 6, so I've got 5 plus 3, which is 8, divided by 0, and so the gradient is undefined.